Let's say that we have 4 siblings right over here, and they're trying to decide how to pick who should do the dishes each night. And so the oldest sibling right over here, he decides, well, look, I'll just put all of our names into a bowl, and then I'll just randomly pick one of our names out of the bowl each night, and then that person is going to be, so this is the bowl right over here, and I'm just going to put 4 sheets of paper in there. Each of them is going to have one of their names, and then he's just going to randomly pick it out each night, and then that's the person who's going to do their dishes. So they all say, well, that seems like a reasonably fair thing to do, and so they start that process. So let's say that after the first 3 nights, that he, the oldest brother here, and let's call him Bill. Let's say after 3 nights, Bill has not had to do the dishes. So at that point, the rest of the siblings are starting to think maybe, just maybe, something fishy is happening. So what I want to think about is, what is the probability of that happening? What's the probability of 3 nights in a row Bill does not get picked? If we assume that we were if Bill was truly randomly taking these things out of the bowl and not cheating in some way, what's the probability that that would happen? That 3 nights in a row Bill would not be picked? And I encourage you to pause the video and think about that. Well, let's think about the probability that Bill's not picked on a given night. If it's truly random, so we're going to assume that Bill's not cheating. So assume truly random, and that each of the sheets of paper have a 1 in 4 chance of being picked. What's the probability that Bill does not get picked? Well, the probability that let me write this. Bill not picked on a night. Well, there's 4 equally likely outcomes, and 3 of them result in Bill not getting picked. So there's a 3/4 probability that Bill is not picked on a given night. Well, what's the probability that Bill's not picked 3 nights in a row? So let me write that down. So the probability Bill not picked 3 nights in a row. Well, that's the probability he's not picked on the first night, times the probability that he's not picked on the second night, times the probability that he's not picked on the third night. So that's going to be 3 to the 3rd power, or 3 times 3 times 3. So that's 27 over 4 to the 3rd power. 4 times 4 times 4 is 64. And if we want to express that as a decimal, so that is 27. Let me get my calculator out. That is 27 divided by 64 is equal to, and I'll just round to the nearest hundredth right here, 0.42. So that is equal to 0.42. And so this doesn't seem that unlikely. It's a little less likely than kind of even odds, but it's not, you wouldn't question someone's credibility if, there's a 42%, roughly a 42% chance that 3 nights in a row Bill would not be picked. So this seems like, if you're assuming truly random, that it's a reasonable, your hypothesis that it's truly random seems that there's a good chance that you're right. There's a 42% chance you would have the outcome you saw if your assumption is true. But let's say you keep doing this and you trust your older brother. Why would he want to cheat out his younger siblings? But let's say that Bill's not picked 12 nights in a row. So then everyone's starting to get a little bit suspicious with Bill right over here. And so they say, well, we're going to give him the benefit of the doubt, assuming that he's being completely honest, that this is a completely random process. What is the probability that he would not be picked 12 nights in a row? Well, just write that down. So the probability Bill, and it's really the same stuff that I just wrote up here. I'll say Bill not picked 12 nights in a row. Well, that's going to be 3. You're going to take 12 3/4 and multiply them together. It's going to be 3/4 to the 12th power. And what is this going to be equal to? Well, let's see. If you take, 3/4 is, I'll just write 3 divided by 4, which is going to be 0.75. to the 12th power. Now, this is a much smaller. This is now, if we actually, this is going to be 0.3. I guess we could go to one more decimal place, 0.32, or we could say, so this is 0.032, I should say, which is equal to, so this is approximately equal to, let me write that, which is equal to 3.2%. So now you have every right to start thinking that something is getting fishy. You could say, well, look, if there was, and this is what statisticians actually do, they often define a threshold as, hey, if the probability of this happening purely by chance is more than 5%, then I'll say, well, maybe it was happening by chance. But if the probability of this happening purely by chance was, and this is the threshold that statisticians often use is 5%, but that's somewhat arbitrarily defined. But this is a fairly low probability that it would happen fairly by chance. So you might be tempted to reject the hypothesis that it was truly random, that Bill is cheating in some way. And you could imagine, if it wasn't 12 in a row, if it was 20 in a row, then this probability becomes really, 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 really small. And so your hypothesis that it's truly random starts to really come into doubt.